All right, let's go ahead and work through these practice problems. So we are trying to take these numbers and write them in scientific notation. So remember, we're going to have a number here, and it's normally going to be in a decimal form. And then we're going to have times 10 to the something. And their exponent is going to be important as well. So remember, when we're writing the M portion, we need one non-zero number followed by a decimal, and then any remaining digits. So for our number one, 628, our first non-zero number is the 6. So we're going to write 6 decimal, and then the rest of the numbers, 2, 8. And then we're going to put times 10 to the, and now we need to figure out what that exponent is. So remember, we are going to plant our pencil where scientific notation is telling us we have to put the decimal, so right here, and we're going to move it to where it wants to be, which is going to be after that 8. So we're going to move it 1, 2 spaces to the right. So because we moved it 2 spaces, that's what our exponent is going to be. When you move the decimal to the right, your exponent is always positive. So our scientific notation is 6.28 times 10 to the 2. So for the next one, we have a really large number. So remember, we're going to first start by writing the M portion of our formula. So that's going to be 7.21345, because remember, only one non-zero number can go in front of that decimal. Now we have to figure out what our exponent is going to be. So remember, when there's not a decimal shown, we just assume it's after that last number, right? 0.0. So if scientific notation says the decimal has to be here, how do we get it to where it wants to be after the 5? We're going to move it 1, 2, 3, 4, 5 spaces to the right. So again, we moved it 5 spaces, and because we moved it to the right, our exponent remains positive. All right, so number 3 is 10. So again, we write 10 as 1.0 times 10 to the something, okay? Well, if I have to put my decimal here, I need to move it 1 place to the right in order to get it where it wants to be. So that would be 1.0 times 10 to the 1. Now notice what these examples have in common. The exponent is positive. So remember, if your starting number, so 628 or 10, if the number is larger than 1, your exponent is always going to be positive. For the last 3 examples, notice that these numbers are smaller than 1, so we know our exponent is going to need to be negative. So again, when we're going to first write this M portion, we have to find the first non-zero number. So that's going to be 2. Then we write the remaining digits after the decimal. So in this case, it's 2.4 times 10 to the what? Now, I've already told you it's negative, but I want to show you why. So here, we're going to plant our pencil where scientific notation says the decimal has to be, which is between the 2 and the 4. How do we get it back to where it wants to be? We're going to move to the left 1, 2, 3. So move to the left, making that a negative number, 3 spaces. So 2.4 times 10 to the negative 3. So we're going to take the same approach for number 5 and 6. I recommend you pause and try these on your own, and then come back and listen. So for number 5, our first non-zero number is 9, with the decimal and the rest of the numbers, which is 1, times 10 to the something. So I'm going to plant my decimal between the 9 and the 1, and then I'm going to move it to the left. 1, 2, 3, 4, 5 spaces. So to the left, 5 spaces. And then finally, for number 6, my first non-zero number is 2. Write my decimal and the rest of the numbers times 10 to the. So scientific notation says I have to put my decimal right here, and I've got to move it to the left 1, 2 places. So to the left, 2 places. So again, because this is a small number, our exponent is negative. All right, y'all. I recommend that you get a blank sheet of paper and try this again on your own. and then rewatch this video if you need any assistance. As always, you're welcome to reach out to me as well. Have a great day, y'all.